Hi there, it's Dr. Embuddy, and this time we're looking at Project 4. We'll be using functions such as we used in the Lab 4. And this one is due the Monday after the exam. And it's just a little cryptography. We give you some functions or some algorithms for how to do cryptography and how to encrypt and decrypt characters, and then we ask you to take strings and then encrypt and decrypt them. There's actually two types of encryption that we're using. This gives us more functions, so letters and numbers get encrypted with one type, and then punctuation gets encrypted with the other type. So let's take a look at it. There are two types of ciphers that were used here, and there's an equation that shows you how to do it. Right? This is how I encrypt something. And the way you're going to do it is, this says to encrypt an X, but what we want to do is actually we have to make X a number. And so if you have the letters, you have A and you have B and you have C and you have D and so on, then we're going to use the value of X as that index. And then we have two other values here. We have an A and an N. Okay, and they're the keys of the cipher. N is what is often referred to as the rotation, and it has to do with how you might do this by hand. And it's sort of the rotation that, in the sense of how you rotated strings in Lab 4. And this is an input to the program. So it's like we give this key once at the beginning of the program, and then we'll take a bunch of strings that we'll encrypt and decrypt and so on. And so this is one of those, and that's that is an int. A, we actually, I'll talk about it a little bit, but it's actually a number that we have to choose, and it's when the A and the M are co-primes, and I'll talk about that in a second. The number M is the size of the alphabet. So, for example, if you have 26, if you're looking just at English letters, there's 26 English letters. If you're looking at English letters and digits, it's 36. So that is how big the alphabet that we're working with. So so we'll have an alphabet, and then the size of that alphabet. And by the way, the function len is good for that. And we're given n at the beginning of the program, and then we have to calculate an A. So the function itself for encryption looks like this. So first thing we do is we figure out how many characters are in there, and we use len. Then we will calculate an A, getting the smallest co-prime. And the only reason we're doing the smallest is so that we're all using the same one. Okay, and it's actually the smallest one that's bigger than 1, and that's explained below. Then what we do is for the character to be encrypted, we find its index. That's what I mentioned before. And then we have the A, we have the X, we have the N, and we have the M. So I can do this formula, and remember that mod is the percent operator. Okay, that's the, otherwise known as the remainder. So we do all, once we have the A, the N, and the M, then each time we can just keep encrypting characters. And so we now, so when we apply that formula, we get another index. Then we have to go back into the alphabet and get the character, and we'll return that character. And so this is to encrypt one character, doing it one at a time. We do something similar to decrypt. And so we have a decryption algorithm here. The biggest difference is, or there's a couple of differences. One is that we have a to the minus 1, and we actually give you that function. So, how do we calculate that function? We give you that function. And then you have an X, an N, and an M. Be a little careful. Notice there is subtraction here. And the parentheses are organized a little differently. It's A inverse on the outside, and then the parentheses. And if we compare that to the other formula, can't quite get them on there, notice how the formula is a little bit different. A is on the inside of the parentheses. Right? And there's a plus sign rather than a minus sign. So just be a little careful that if you're doing some copying and pasting, that you don't get into trouble with that. And then very similar is the Caesar cipher. Okay, so this is slightly different, but it's the only real difference is that there's no A. Okay. And so the algorithm is pretty similar to the affine one that we had above. Looks kind of messy, but it's just four-step algorithm, and you just have to pay attention. So we have 8 functions, and we give you a file with the functions in it. And you have to fill in the good stuff on the inside. We give you the entire function for the multiplicative inverse, and then for the others we give the skeleton of it. The name, the arguments, and then there's this thing called pass. That's just filler in there, and you have to delete that and replace that with your own code. But this code will actually run. It won't do anything because these functions don't have anything in them, but that lets you build the functions one at a time, and you won't get any error messages. We also give you the punctuation. We import the string and we get string punctuation, and then we create this other constant, which is the lowercase letters and the digits. Okay. So we will be working entirely in lowercase. So if somebody gives you an uppercase letter, you got to make it lowercase. That's traditional in encryption. They either do it all uppercase or all lowercase. We're trying to not provide clues to the enemy. And you will also notice that in here there is no space character. So that means that the space character is just not part of what we work with, and again, that's traditional in terms of encryption, because spaces occur frequently and can provide clues to somebody who is trying to crack your code. So we have it's just letters and digits, no spaces. So if you decrypt something, you have to use your own intelligence to figure out where the spaces need to go. Again, that's traditional cryptography there. So all the functions are given some space there, and then we have this special function at the bottom called main. And then we have this weird stuff that looks like that. And what this does is that if you just run the program, then you will call main. But if this program gets imported into something, main won't be run. Why does that matter? That's how we test on mirror. So so what happens is everything that allows us to test functions individually on mirror. So this format that you have here, you got to use that. Otherwise, our test won't work, and that's not a good thing. So here we specify each of the functions, and let's see, do we have them all in here? Let's see, there we go. And for each of these functions, let me take something like the Caesar encryption. Right, we're encrypting here. It takes a character to that you're going to encrypt. So this is just one character. This function handles one character. It doesn't handle a string of characters. It handles one character. And then the rotation that we input at the beginning, and then the alphabet that we're working on. For example, are we working on just letters? Are we working on letters and digits? Are we working on punctuation? That's what goes in there. I don't tell you much about that. Notice that it returns a character, doesn't return the index, it returns the character. And what goes in here? Well, it's the algorithm that we described above. And so there's a Caesar encryption and decryption, and then there's an affine encryption and decryption. Right? And to support those functions, there's getting the smallest coprime. That's our A value there. And then to help out with that is this, we call the check coprime. Oops, I've got a typo there. That should be C. I'll have to fix that. And that just checks if two numbers are coprimes of each other. And I say, boy, another typo there. To use the GCD, greatest common denominator, and you can, for example, find that in the math. So you'd want to import math in order to do that. You can write a GCD function if you want. That's okay. But the easiest thing to do is the one in the math, and then all the good stuff that calls these functions is in main. All right, and so we have a bunch of tests of the individual functions. So, for example, if I look at the Caesar cipher, in this case, if we're encrypting, if I'm going to encrypt the letter A, and my key or my rotation is 3, and there's my alphabet, which is part of our lowercase letters, then the result will be the character D. And I will use these other two functions, or I may use those other two functions. I guess I use them in the affine. Maybe I didn't use them in the Caesar. Okay, so we have again we encrypt, we decrypt, and notice here that I did these. I set these tests up. So encrypting A, we got D, and so when I decrypt D, we should get back to A again. And the same thing with E gives me 8. 8 gave me E. Same type of thing happens with the affine encryption and affine decryption. So let me show you how you might test these things. So a couple of things. One is that you can highlight a function and then choose run and run a selection, and now that function is available for you to use. So what is the multi... and I can give it two values. The multiplicative inverse of 2 given 26 alphabet, and it's not defined. I thought I ran it. Hold it. I must have a typo. I can't spell. That's what the problem is. We'll do it this way. Of course, it didn't know what I typed it wrong. So we'll do that. And if you look here, you can see that watch in here. There's a little bit of a clue as to what arguments that you use there when you type that. So you have multiplicative inverse. You can see the arguments are there. We'll go 2 and 26, and it didn't return anything. Oh, because I gave it values that it wouldn't that it has no value for. So let's pick something like there we go. So yeah, you've got to have a multiplicative inverse has to exist, which if you have built the A and the M correctly, that ends up not being a problem. But the point here is that I can highlight a function and then run it so I can test it by itself. I also have in here, let's actually take an example here. Because I ran my program, I can try to take that encryption, and you see that I do get the letter D. And now if I want to use the same thing and decrypt that, take the D and decrypt it, notice how the so these are, so I've got Caesar and I've got Caesar. We've got encryption and decryption. When I started with an A and a key of 3 in a language of A, B, C, D, E, F, G, H, the result was a D. If I then put that into the decryption, I should come up with an A, which I do. So the encryption and decryption should be inverse operations. And so that's looking good. And you can go through and test each one of these individually. Mirror will also test them. Now, what if I wanted to encrypt a string? All right. Well, I could say for character in my string, and each time I can, and notice how we get a clue here as what my arguments are. So I'll get my argument. We'll have, let's use 3 again, and then my alphabet is those letters. Now, what might I want to do with this is print those. And so now I see that I've gone through this and encrypting D, E, and F, and I get the characters G, H, and A. Okay, so using the Caesar cipher rotation key of 3. Now, there are actually, you're going to do something different in the your actual program, because you have to say, oh, well, if I have a character, I use one type of encryption, and if I have a punctuation, I use the other type of encryption. The alphabet, of course, will be different, and the key will, the rotation will be whatever value is input into your program. So if we look at how a run looks, we start out with a rotation, okay, and that'll be an int. So in this case it was a 4, and then you have a command, and so you either enter an E to encrypt, a D to decrypt, or a Q to quit. So if I enter an E, I say, what do I want to encrypt? I put hello world. And then I print out both the plain text and the cipher text, the hello world and its encryption. Notice no spaces in there. All right. And now let's see if I can reverse that. So I did a decrypt. I took this string here and I copied it down here, and you see we end up with hello world, all lowercase now, because my encryption was only using lowercase. If I do another one, we encrypt Fahrenheit 451, a great book if you've never read it. So the plain text is that. The encrypted text is this weird looking stuff here. And then if I take that and copy it in here with decryption, I get that was the cipher text, and the plain text comes out as Fahrenheit 451 and a Q to quit. So there's the basic idea of what we're doing. This is how encryption works. You go through, you take a string and you work your magic on, in this case, individual characters. The modern encryption and decryption works on chunks of characters called blocks. But the idea is basically the same, and you can see here with this, even with this simple looking, simple kind of encryption that we're doing, we can really end up, how can you see that the ciphertext and the actual words are at all related, and that in fact is the key to this whole thing. All right, good luck.